Good afternoon, all of you. Uh, in this class, we are going to see about traveling salesman problem. So I want everyone to have take notes on it. Okay. So what is this traveling? A traveling salesman problem means actually a traveler want to travel between cities. Okay. The main thing here he have to do is he should not go to the same city one more time. So you from the starting point he have to travel and reach the cities and he have to come back to the original place from where he have started. So that is what we are going to see in this traveling salesman problem. Um, so let me explain you with an example. So consider we have a traveling salesman. He want to travel from this place called A, and he want to go to other places called B, C, and D. Okay. So all the nodes are by both way connected. Okay, bi-directional connected. So this is also connected like this, and this is also connected. So here, the objective of the traveling salesman is like he can start from A, and then he can go to B, then he can go to C, then to D, and finally he have to come back to the starting place. This is one option for the traveling salesman. What is the another option? He can start from A, and then he can go to D. After going to D, he can go to C, then to B. Finally, he can reach A. So this is what we have to do. So he have to go to all the cities here and only one time, and finally he have to come back to the place where he have started. But this should not happen. For example, he can start from A, going to D, and then going to C, then to B, and then to D, and then to A. So this should not happen because if you see, D is visited for two times. So here he have to visit each and every city for only one time, and finally he have to go back to the starting point. So this is our problem. I think you can relate it with our real time scenario also. Okay, so for this problem, we this for this graph, an adjacency matrix is also given for you, where we can see the traveling cost from one point to other point. So here, if you see, there are totally 4 points available. That is A, B, C, and D. Similarly, here this will be given in the given. Okay, so to itself, you know, always the cost of traveling to A and B to B and C to C or D to D is 0, and the rest of the things, this is already given for us. What is the cost of traveling from B to A is already given as 8, 13, 16, 4, 7, and finally 9. Here it is 5, 12, and 2. So this is what the cost of traveling from one point to other. For example, since it is bidirectional, I can go from A to B and also B to A. Similarly, I can go from D to A or A to D, something like that. So here you can understand the cost of moving from A to B. A to B is 16, and the cost of moving from B to A is 8. So you can so all this thing are given. Sometimes traveling from A to B, the cost is 16. From B to A, it is 8. Sometimes it may be one way. So when you come return, you have to take another path. So maybe the cost may also vary. So this is what the adjacency matrix, which shows the cost of traveling from one point to another. And I hope you have understand the objective of this traveling salesman also. Okay, so we have to solve it using dynamic programming. You can solve it in many different way, even using brute force method. All these things are greedy method. Anyway, you can solve, but solving it using dynamic programming, we know we'll be getting a better result. Okay, so here, so to before I teach you the formula for this problem to solve, let me illustrate this with a graph, or I can show you with trees like structure, so that from that you can easily understand how well you can derive to the equations. Okay, so here our objective is we are going to start from A and again come back to A by visiting all other city only once. So here let us start from the place A. So if I start from A, what are the other possible way to move? From A I can go to B, or from A I can go to D, or from A I can move to C. So I am going to write all different possibilities. The possibilities are B, C, and D. Okay, so these are the three different possible way where I can go from A to A. So I can go to B, C, or D. Okay, then let us come to B. When I come to B, what are the other possible way according to the condition? I can go to one, every place should be visited only once. So we came to B. So what are the other two possible ways? We can either go to C, or I can go to D. So these are the other two possibility for B. For example, if here is B, either I can go to B or I can go to C. These are the two possibilities, right? And then when I come here, C. So from C, where can I go? So everything should be visited for only one time. So from C, I can only go to D. Okay. Similarly, after because A, B, D is there, and one more city which has not visited is C. And for C, what are the other two places I can move from C? I can go to B. Also, I can go to B. So you can see here in this from C, either I can go to B or I can go to from C, either I can go to B or go to D. So from B, where can I go to D? And from D, where can I go to B? Right? And from D, where are the other two options I can go? One is I can go to B, other one is I can go to C. From B, where are the other place I can go? Can someone tell me where are the other place I can go in this case?
C.
Good, Marcy. Good. So from B, only other option is B. And from D, I can go to someone else.
B.
Very good, Ma. B. Good, Ma. So we have so only once only we have to visit the remaining cities. So accordingly, we have drawn this tree, and finally, after we come here, according to our original solution, we have to go back to the starting location. So we know that. So once we reach all the other cities, then where should I go back from D? From D, where should I go now? Where should I go, Ma? So I have started from A, I visited B, C, and D. So finally, I have to go to which place?
A.
A. Very good. Thank you, ma'am. Good, excellent. You are listening. So similarly for all the other places also, we started from A and then we go to B, D, C, visited all the city only once. Finally, we have to go to the starting location where the salesman started. So here also, all the other places we have to go to the starting point. Here we have taken the starting point as A. So finally, from here we have to go to A. Okay, so now we have to find through which way if he goes, he will be having the minimum cost. So that is what we want to find, right? So that we are going to find. So let's take this situation. Say for example, if I want to go from D to A, what is the cost? From if I go to, so if you see this adjacency matrix, so if you see in this graph, I have to know what is the cost from moving from D to A. So D to A, the cost is 5. Okay, and then what is the cost from moving? Similarly, I can find for all. What is the cost from C to A? C to A, it is 4. Similarly, what is the cost from moving from D to A? D to A, this is D to A is it is 5. Okay, and similarly moving from B to A, B is here, A is here. So the cost is 8. C2A, it is 4. And B2A, the cost is 8. Okay, we know that. Now we have to again find what is the cost from moving from C. Okay, so we have to find what is the cost from moving from C to A. Okay, so already we know moving the cost of moving from D to A, we know already that is 5. So first we want to find what is the cost of moving from C to D. So C to D, the cost is 9. So here it is 9 plus the cost of moving from D to E is already found, right? Is 5. So 9 plus 5, this is equal to 14. So the cost of moving from C to A is 14. Similarly here, already we want to find the cost of moving from D to A. So already C to A is already found. We want to find from D to C. So if you find D to C, the cost is 2 2 plus, and the cost of moving from C to A already we know it is 4, so which is equal to 6. Okay. Okay, so similarly the cost of moving from B to D, what is B to D is 16. So 16 plus 5, which is equal to 21. Then cost of moving from D to B, D to B is 12 plus 8, which is equal to 20. And then cost of moving from B to C. B to C is 13. 13 plus 4 is equal to 17. Then cost of moving from C to B. C to B is 7. 7 plus 8 is equal to 15, right? So we found the cost until this. So now again we want to find from B to A. So now if you see here, if I want to reach from B to A, I have two options. Either I can go through B, C, D, A, or I can go from B to D, then from D to C, then to A. So which route is suitable, we have to find a minimum cost. So again we have to find the cost for this and the cost for this, and we have to find the minimum of it. Okay, so what is the cost from moving from B to C? B to C is, that is 13. 13 plus, and this cost 14, because already from moving from C to A we already found, right? So 13 plus 14 is equal to 27. Similarly from B to D, B to D it is 16. So 16 plus, already this cost we know 6, so it is 22. Okay, so similarly, C to B, the cost is 7, 7 plus 21 is equal to 28. And then cost from C to D is 9, 9 plus 20 is equal to 29. Then D to B is 12. You can take notes, kindly take notes. I will check your notes tomorrow. 28, 29. And here from D to C, it is D to C, it is 2. 2 plus 15 is 70. Okay, so now again, so we found from cost of moving from B to A and B to E. This, now we have to find the cost of moving from this, which path is better one I have to find, right? So I have to see. First, I can say the cost of moving from A to B. Cost of moving from A to B is 16. Now we have two things. Either I have to choose this path or I have to choose this path. So among these two paths, which will you choose is the minimum one? Okay, sorry, ma'am. So here, along with 16, now we have two ways to go, right? Either you can choose this way, or you can choose this way. So which one will you choose? We have to choose the minimum one. So here you can say 22. I can choose. So I will say 16 plus 22 is equal to 38. Similarly, from A to C, the cost is 11. 11 plus, if you see here, I have again two ways to reach A. One cost is 28 and the cost is 29. So here again we have to take the minimum, that is 28. So I have to say 11 plus 28 equal to 39. Again from A to D the cost is 6. 6 plus, now we have again two parts. 29 is the cost of this path and 17 is the cost of this path. So we have to choose the minimum one. So we can choose 17. So plus 17, you will get the answer is 23, right? Okay. So now from this we can choose which is the minimum, which path will be the minimum again, which path is the which way we have the less cost. So if you see here again, this is 38, this is 39, and this is 23. So this is the minimum cost. So if I want to travel from starting point A and if I want to reach all the other path, all the other cities, and finally if I want to go to the starting point, which path is better is this path. I can go from A to D, D to C, C to B, and finally I can reach A. So that is the path, and which produce the less cost to travel also. So this is what our problem. This is what our problem, and we found the solution for this. So we want to find. I want to travel to all the cities, and then I have to come back to the original starting point, and all the cities should be visited only once. So from this, we are going to derive the formula. Okay, so if you understand this tree, you can easily write out the formula also. Let me write the formula. So we want to find the cost of, for example, g of, okay, right. So g of moving from a starting point I, and I want to go to a particular S. What is I and what is S means? I denotes the starting point. Okay, I denotes the starting point. Okay, this I denotes the starting point. And what is this? Yes, yes is a set. Okay, what does this set says means? For example, if I am starting the starting point A, consider my starting point. Okay. So if my starting point is A, what will be the set? The rest of all the other cities, that is B, C, and D. Okay, this is what the set. So which means what, we have to start from the location as starting point. Then we have to visit to all the cities once and come back to the starting point. So what will be the cost? That is what we want to find. So how will you find this? We have to find the minimum cost, right? So we want to find the minimum cost of traveling from weight of I comma j. Okay, so for example, I want to find the minimum cost from traveling from A to all the other cities, and I have to reach back to A. So I have to say the starting point A is I, and the rest of all the cities is the set, that is B, C, D, which is equal to, have to find the minimum. How will you find the path, the cost from this path to this path? First, what we did, we find the path from A to B. That is what the first thing, right? We want to find the path from A to B. So that is what weight of I comma j. And then along with that, plus g of, then what we did, this thing want to be repeated again and again. Say for example, I'll do this way. For example, first we found path of moving from D to A. So that is what the first thing we found. That may be 5. Then what we have to do, similarly, I have to repeat for all the other cities. So I am going to recursive, it's like a recursive function. So again, same thing I have to do once again. Then I have to find the path from C to D. Then I have to find the path from B to C. And then I have to find the path from A to B. So this is want to be repeated. So this function need to be called again and again. So when I move from I to J, so now I reach the point B, right? So here in this case, I is A, J is B. So when I call the function B, G, again, this is what the G function, okay? This is what this G function. In the G function, you have to say first thing is starting point. Next is set. So here, this is the starting point. This is the first step we reached from A and B. So now, what will come for a G of this place? Let me see who is understanding. Here, what will I put? So again, I'm calling the same function, okay? The same function is calling. If I want to call the same function, first value should be the starting point. Second value should be the set of set, which means the rest of all the other cities which I want to visit. So first thing is first we what we'll do, I'll start from A and I'll go to the first city. So that is what I comma J. Now for the rest of all I have to find the same procedure by repeating it in again. So that is why it is again a recursive call. So when I call this function once again, what will be the first value here I'll get? What will be the first value? Nobody understood?
S of I.
Madan. Okay, S of I, Amma. What is S of I? So here, what is the next
It's
starting point? So here, see, you look at this graph. I reached from A to B. Now I have to repeat this step again and again. That is why I'm calling this recursive function. This recursive function, when I call, this is what the function. Same G. In the G, I have to give the starting point, then the set. So what will I give here? I think nobody understood. See, again I'm saying G, when you call a function of G, this is a function calling, okay, I put square bracket, it can be parenthesis. So when I call the function G, the first value should be the starting point. So here what will come? Where are you now at present? We moved from I to J, which means we've moved, in this example, we moved from A to B. So what will be the next starting point?
J.
Excellent, so then, super. J. So now J comma, my eraser is not working, sorry for that. It's coming. I'll rewrite again. Okay. So G of, I'm calling the same function, okay, same function. So the first variable or parameter is J, which means first starting point. Then, can you say this? What will come here? What are the other place I have to visit? What are the other place visit? Yes, minus
B.
J. Okay, so because already J is visited, okay, so because J is visited, now when I move from A to B, that is what where cost of weight means cost of moving from I to J, that is A to B. Then what I have to do, I have to again from B to, then rest of the thing I have to call again and again. So I don't want to visit B again. So from the rest of the set, which means what is the rest of the set? B, C, D. So B is already visited because B is the starting point now, the rest of all. So it will come comma like C comma D, which means from the set, remove the J. So S comma J, which means from the set C and actually now the rest of the set is B, C, D. Now we again visited the city B because we moved from A to B. So the rest of the set is C comma D. So from the set B, C, D, we have to subtract this location, the starting location, that is B. So S minus J. Okay, I hope you got it. If you understand this graph, you will understand this formula, which means what is the actual problem? We want to move from the starting location, visit all the cities B, C, D, and again come back to the starting location. So what will you do actually? First we will move from A to B. So that what is the cost of moving from a starting location, that is I, this is I, comma, a intermediate city. So that is J. So that is either you will go to A to B or A to C or A to D, whatever it may be. So any one city you will be visiting. That is I comma J plus. Then how will you find the rest of the path? Again I have to call the same function. It's a recursive function. Once again I call the same thing. Which means what for then I'll find what is the cost of moving from C to B. Again a recursive call. Then I want at that time I have to subtract C because I already C is visited. So the rest of the thing. So I'll be subtracting the already visited city. So the already visited city here is J. So S from the set remove the J. So which means C will be removed. So the rest of the thing is B and D. Again a recursive call will be made. So the starting location there will be B and then B is already visited. So from the set I will be removing B. Then I have to find the same function by passing D inside. Okay. So this is how we have to find. We will. This is what the formula also. So I'll write the formula once again, which means G of traveling cost of moving from source to destination by visiting all the cities is starting location, comma, then the set. So for example, if my starting location here is A, so then what will be the set? A is already visited. So the rest of the thing is B comma C comma D. Okay, that will be the set. And then which is equal to minimum cost of, because we have so many other paths to travel. This can be one path, this can be other path, this can be so whichever path we are going, in that we have to take the minimum. So that minimum of first cost from moving from starting location I to a jth location plus again the function called repeating. Here now the starting location is J because we reached the place J comma the subset or the remaining set, which means from the set take away the J. Okay, now let us apply this. Okay, this using this formula, let us find the best solution. So what is our objective? Our objective. So let us apply to this formula. Our objective of finding cost is G of. Where should I start? For this problem, let us use this formula. So our starting location here, let us take as the traveling salesman is starting from the city A. Okay, so his starting point is A. And what is the rest of the cities now available? Once A is reached, it will be B, comma, C, comma, D. Okay, so this is the rest of the city. So then I want to find the minimum cost of what are the other possible minimum path I have for it according to this formula. One path is I can say weight of moving from this subset. I can go to any path because I can go from A to B, or I can go to from A to C, or I can go from A to D. Okay, you can see in the graph. When I start from A, I have three options. Either I can go to A to B, or I can go from A to C, or I can go from A to D. Okay, so that is what we are going to see here. So cost of moving from, let me first move from A to B. So first we chose this path. Let us consider. So A to B. So then according to formula, we reach to I, starting point is A, then we reach to city B plus again a function called G of. Now the salesman is in the location B, and again what are the other set he has to meet now? Already A is visited, B is also visited. So the rest of the thing is C and D. Okay, this is one case. One of the cases, weight of starting from A, I can, instead of going to B, I can go to C also. So if I go to C, then what is the other recursive function? For example, now I came from A to C. So the rest of the things, either I can go from here or here. So again for this, I have to make a recursive call. Either B to D or D to B. We will write it once again for the recursive call. So here, now the trade salesman is in the city C. And what are the other rest? I have visited A and C. So in this A is visited. So in this set, C is now visited, right? What is the other two places? B and D. Okay, and then one more option is all there. Starting from A, one more option in the set is D. So one more option is D plus. Can you fill this now? Please help me to fill this, ma. G of what will come here? What will come here?
D.
Yeah, D, comma, What will be the set? Good, so then you are listening. Others also you can try. What will be the set?
B,
B,
C, ma'am.
Ah, very good. B, comma, C. Exactly. Good, good. So, because why? In this set, D is visited because the salesman is in the place starting location D. So, D is done. What are the other two places? B and C. Super. So, now we have to, if we want to find a solution for this traveling salesman, we want to find the answer for all these values. Then, which is coming minimum, we'll substitute here and our answer will be there. Okay. Okay, so now we know what is the weight. Okay, now we have to solve all this thing. We want to find a minimum of all this path, right? Already we manually we calculated and we found. Now using this equation, I have to find the path by this way, then by this way, this way, this way, this way, and this way. So 1, 2, 3, 4, 5, 6 paths are there. So all this I have to find one by one, and then again we have a recursive call. So now the cost of moving from A to B, or weight of car moving from A to B, already we know it is 16. But what we doesn't know, it is a recursive call, right? Again I have to call this function once again by this as a input. So now if I want to find the answer for this, then what should I find? First I want to find the answer for this part, and this part. So let's start by one. Let's move one by one. Okay. So first let us find cost of moving G of this one. Okay, this part we want to find. G of B comma, the starting location is B, and now the set is C comma D. So how will I write the formula? Can someone tell me? Minimum of, tell me ma. What will come here? For this input, what will be the answer? Weight of. What is the starting location?
B,
Yes,
B, ma'am.
exactly. Superma. So from B, when he start, we have two options. Here you can see. He came to B. Now he again have two options, either C or D. Okay, so we want to find for both. So, but one by one. So B comma what we can use? B comma
C.
C. Now one by one we can. First let us go for C. So if so, then what will come first? G of, for G, he came from B to C. So what is the now starting location?
C, ma'am.
C,
Superman. நல்ல பிள்ளைங்க. Sudan and Tracy only is listening. What about others? So I can expect answer from others also. Okay. So what will be the set this time? So now this is the two place, other two cities we want to visit. That is C and D. Now C is visited. So what will be coming inside the set?
D, ma'am.
Superman. Because this is what the place, other two cities we want to visit. So here we came to C. So one more, only one city to be visited is only D. So we wrote it. Okay, done. What is the other one option? This time we chose to go from B to C. What is the other one option we have? Start from B and
B
go
to
to
D.
to D.
D. நல்ல பிள்ளை. Very good. Shavani, right? Okay, Tracy also. Then, so we went from B to D. So, which means what? This path we took. From B to this path we came. So, for that also we have to find. So, again, G of now the person came from B to D. So, now what is the starting point? He is in which location now?
B, ma'am.
Comma. Super. Then, what is the only value in the set?
C.
C. Super. C. Okay, done. So we, for when we start from B, we have only two options, C and D. So that we did. Then again for C there is one option, from D there is one option. So again there is a recursive call here, right? One more time we want to write. We want to find the value for it. Then only we can substitute here again. So now this time we want to find what is G of C comma D. Okay, so now again we have to write the formula. This time only one value only, because we automatically know there is only one thing in the set. So if you don't put minimum also, no problem. But still, to make you to understand the formula, let me write me. Because you can see when you go from C, there is no other option. Only thing he can move is C to D only. So can you now tell me what will be the formula? Weight of moving from
C. D.
what
C,
is C? comma
D, ma'am.
D. Very good. Because no other option. I'll apply Jaden also. Okay. Plus G of, I'm happy that you're all listening. Good. God bless you, ma. I hope that others also listening, but you're not answering. I can expect from others also. Now, can you say now G? What is the next starting location for G?
D, ma'am.
D. What will be in the set now?
A.
A. Somehow it is correct only, Jaden. But actually, in the set now, as of now, we have D only. Now we visited D. So what will be in the set? Nothing, right? So this is the one. Usually we move from B to C, then we go for B to D. Here only one option. For that only a finding. Now D to null. Actually, Jaden, what you said is correct. If I want to find this value, for example, what is G of D comma null means? It is like weight of this. Actually, first I'll write the general formula somewhere. Here itself I'll write. So whenever we have a value like this, g of some x, some location, comma 5, whenever we have like this, so then how will you find the cost is the weight of x, comma I. What is I? The starting index. So Jaden, what you said is correct only because from that location finally, when you reach D, finally we'll move A only, but directly first you write null, nothing is there. Then we know obviously from D we have to move to A only. So it is like moving from D comma A. Okay. So now we can do everything. So now we found for G of C comma D. Similarly, we have to find for this one also, right? Then only we can finish that as well. So we have to find what is G of. Tracy, anything to
Ma'am, could you please
clear?
show that formula, ma'am? What you wrote just now?
What, ma?
From the formula, what you wrote for a null set.
Uh,
Could you please
okay.
show that?
Yes. Here it is. Which means in this table once we reach D, sorry, once we reach D, after that no place to go. So where will you go again? To the starting location. That's what it says. So when we reach X, then nothing is there means finally we connected with A, right? Which means the starting point. That is what X comma null means the weight of moving from X to, again now we have to connect it to the starting location. That is I. Have you
Yes,
noted,
ma'am.
ma'am?
Thank you.
Okay. So now the next part to be found is this part, right? This part. So we have to find, so already we found this. So now we want to find D comma C. We want to find the answer for it. Again, minimum of weight of D comma C plus G of C comma null. So we know what is, so that's the only thing. So what is G of C comma null, which means it is equal to weight of C comma A. So now we derived all the parts. Now we have to substitute the value for it. Okay. So what is C comma A? What is the cost of moving from C to A? So 1 second.
4, ma'am.
4. Very good. So let me take it. Okay, so now the cost of moving from C to A, what is C to A is 4. So this we know as 4. Now we can substitute here. What is cost of moving from D to C? If you have noted in your notebook, you can see and tell me. What is the cost of moving from D to C? Anyone?
2, ma'am.
Exactly, super. 2 plus the cost of moving from C to A, already we found 4, which is equal to 6. And similarly here, what is the cost of moving from D to A?
5.
5, very good. So let us substitute this here. So here, what is cost of moving from C to D? 9, right?
9.
9 plus 5, which is equal to 14. Now we can, so this, now we found the value of this one as well as this one. Let us substitute it there itself. So if you substitute it, here you will get which is equal to, what is the cost of moving from B to C?
13.
13 plus what is g of c comma d?
14.
C comma D, where it is? Here it is 40. So the answer is 27. For this, what is B comma D? It is 16, right? 16 plus D comma C we found is 6. So it is 22. So from this you can understand which is the minimum value. So the amount, the minimum,
22.
22. So this one you can see here also. We got this path. From these two paths, we found this is a minimum path. Okay. So one way only we found. When I choose B path, in this B path, what is the minimum path? This we found. Now again we have to find when I choose A path, when I move from A to C, what is in this two? What is the minimum? Then if I move from A to D, in this two path, which is the minimum? This again you have to derive through this formula. I hope you got it. Now until this, what we did. Actually, first we started from A, and then this is what we different solution for A to B, A to C, A to D, and then now we found only for this one. For only for this we solve now. Similarly, you have to do for this too. Okay. So for A to B, what is the cost of moving from A to B? A to B is 16.
16.
Plus what is G of B comma C comma D?
22.
22. So what is the answer? 38. Yeah, 38.
Thanks, ma'am.
So in the path, for this path, we now found the cars. Similarly, we have to find for this, and then we have to find it for this. Okay. So this too is the homework you have to do and come. This video and this notes I will put it in GCR. Using this, you have to find this and this answer for this too. It is easy only. You just refer it and you have to finish it and come. Let me see it in the class. Okay. I hope you will all do it. Will you do it? Yeah, shall I get some